let's talk about integration by parts. Integration by parts is kind of what it sounds like. It's where you have two functions, specifically a product or a quotient, and you try to evaluate the integral of that. So what the integration by parts formula is the integral of u times dv equals u times v minus the integral of v times du. You've got to make sure to somehow differentiate your u's and your v's, because sometimes it gets a little confusing when you're writing them over and over again. But so I just put little hooks, but it's okay. So the way to figure out what u is in a product, say here, is using our handy dandy late, right? So our first L stands for logarithmic. So most of the time, logarithmic means ln of x, right? So if you see this before any of these, this is going to be your u. Our next one is inverse trig. Inverse trig. So arc sine of x, arc cosine of x, etc. And then our next one is algebraic. So this is basically like anything involving x. So it would be x squared, x to the third, 1 over x, 2x, anything like that. But you have to make sure that the x is not in the exponent, because that's what our e stands for, or it's not in a ln. Our next one is trig. So cosine of x, sine of x, tan of x, and then the other three. Our last one is exponential. So that's where our x is in the exponent. Exponential. Makes sense. The x is in the exponential. That's how I like to remember it. So it would be like e to the x, 2 to the x, etc. So now that we have late, that's what I like to call it, we have late planned out, let's take a look at this example. Switch out markers real fast. So now let's take a look at our example here. So we have x squared times ln of x. So using late, we can see that ln of x is going to be our u, because it's first. X squared is down here, so it's not going to be the u. ln of x is higher on the list. So u equals ln of x. So now you'll see that we need to fit, and then our dv equals x squared, right? So you'll see that in our formula we have du and v, so we're going to have to take the derivative of ln of x and the antiderivative of x squared to plug in stuff into our formula. So du in this case is 1 over x, and our v is x to the third power divided by 3. Okay? So now let's just plug stuff in and see where that takes us. So u ln of x times v x to the third divided by 3 minus the integral of v, that's x to the third divided by 3, times du, which is 1 over x. So you can't simplify this anymore, but we have to simplify this inside so that we can take the antiderivative of it. So ln of x times x cubed divided by 3. So here I'm seeing a third, so let's just take that out. So it'll be minus a third times the integral of, and here we end up getting x to the third divided by x. So if we just cancel out that x on the bottom, we're going to get x squared. So we can take the antiderivative of x squared. That's going to be the same thing it was up here. ln of x times x cubed divided by 3 minus 1/3 times the antiderivative of x squared is x cubed divided by 3, and then we add our plus c. And that's how you integrate by parts. You can see you use integration by parts basically when you can't use u-substitution in any way, shape, or form, and you can't use any of the other ones like, I don't know, dividing by them or solving for x. You can't use any of those. So integration by parts is really handy here because you can see how awful this antiderivative is, and you probably wouldn't have been able to solve it without integration by parts.